To solve this indefinite integration question by the method of substitution, first we need to take a look on the question itself. We have to replace our independent variable like x and x containing terms with some new term, with some new function, and that's what we do in a substitution method. That makes the question easier, by the way. So here, if you see the beauty of the question, now see, I'm saying beauty of the question. I'm going to say here that, see, the derivative of the thing that we're going to suppose is already present in the question, and I saw that. What is that? See here, 1 plus 2x square. The x is having power 2. It means the derivative of x with power 2 is always 1 less x. Derivative of x square is 2x. Alright, 2 is just a number. We can move up and down. That does not matter. We can write in numerator, we can write in denominator. That's not the big problem. But the power after finding derivative of x square, after differentiating x square, what you'll get? You'll get 1, and that is already present outside. Alright, and I already told you, whenever you have to suppose maximum time. It's not like hard and fast rule, but maximum time. The supposition is the thing that is inside the root, and the thing inside the root is here 1 plus 2x square, and see that's gonna work also here. So let new function t equals to 1 plus 2x square. Alright, and now let me differentiate both sides with respect to x. So dt over dx is now, see, why we suppose this? Because we can reduce this this constant with zeros. That's help us always. All right, that's why I didn't suppose x as a t. Now the derivative of this constant 1 is 0, and 2 is a constant and as well as coefficient, so it is just outside. And now derivative of x squared is 2x. So dt is equal to now 4x dx. And if you rearrange it properly, so that I can write the relation properly, it's gonna be like 1 plus 2x square inside the root times x dx. I'm just putting this x here just in front of dx. Alright, so what I was trying to show you, see this one, x dx, and from here we can make x dx possible. How? dt over 4 is going to equals to x dx, x times dx. So this particular relationship, I'm going to use it here now, and from here next step is integration of, now it's like the 5th step. If you remember the 6 steps of integration by the method of substitution, so it's the 5th step, replacing all the variable containing term with the new term that we introduced here, that's t. Alright, so 1 plus 2x square, that is here, that is here actually t, so it is inside the t. That means the power is having 1 by 2. Alright, because that x inside the root x, that is x to the power 1 by 2. So times, and x dx is actually dt over 4, so it's dt over 4. I'm writing a little properly, 1 by 4 outside, t to the power 1 by 2 dt, and simple process of integration by using the power rule of integration, that's going to be t to the power half plus 1, and definitely a constant. Alright, so now further it's 1 by 4. Actually you don't need to multiply as well, directly you can write constant also. Alright, and now it's t to the power 3 by 2, and 1 by 2 plus 1, that is again 3 by 2. If you want, you can cancel this 4 by 2 times, and again 1 by 4, so it's going to be c by 4, and overall our answer is going to be now finally 2 times 3, that is 6, so 1 by 6, t to the power 3 by 2, and c is arbitrary constant, 4 is also constant, so overall it's a constant. And let me put the values, everything. The original value of t, let me substitute, that is t equals to 1 plus 2x square. So it's 1 by 6, 1 plus 2x square whole to the power 3 by 2 plus constant c, and that's our final solution.